Hello everyone, Alex is here, and let's discover vector search. How does this thing in general works? Let's try. As for me, it's quite not easy topic. But let's try to figure it out. So firstly, let's go to our src folder, and here we'll have our SQL. So we'll be working, discovering how does it works on the SQL side, and basically an idea today will be how we can store that, how it is being searching, and how we can take the, for example, nearest results. So everything is starting from the, of course, setuping our document. So we're taking vectors extension if we're working with PostgreSQL, and for that, firstly, what we should know that for creating such things, for example, documents, we can create table documents. We can have three things: IDs, of course, primary key, content, and embedding. Content is what does it mean? For example, we have the request, we have some answer for our ask, and etc. So that will be our context. What is embedding? Embedding is vector's answer for the specific, not like answer, but what does these words will be in vector. So you know that all the words basically they're like numbers for our database, for our AI, and it's from 0 to 1. So you can see a request for Paris is the capital of France. We're writing our vector. There could be a lot of the numbers, etc., and that will be vector. And we'll put in all of that data to our database, and right now we'll have like the easiest vector that could be. Then we find the most similar document to a query embedding. 5 of them. And how we can do that? It's like just simple variants. So we're just taking select ID and context from documents and embedding. This thing will find the nearest vector that will be to our requests. So it based on what you, for example, you have asked something and it turns it into the vector. With that, tries to find this information. It's like in Google search, you're writing, for example, what you're asking, what you wanted to discover, and it tries to convert it to the vector and then tries to take all the database to discover the similarest vector that could be something like that. It's just the most easy answer that I can create for you. Then we're inserting the data. So that's how it will be looking like. Where you're taking this vector. So this vector is being taken based on your mostly server. So for example, you have the server that you have the search, you're typing something, and you have sentences, and you're trying to discover what you have been searching to that sentences. For example, trying to compare something similar to what you're writing. So vectoring will be doing your server. So it could be some AI, it could be some mathematical methods that will convert your code into that vector. And that's kind of all of how it will be put here. So server will convert your specific sentence that you will be writing into your database. And you can store in this way all the information, documents, some answer to the questions, etc., etc., etc. So for example, you can have more global context. For example, you can have the question here, the vector for that question that will be linked to an answer, for example, or something like that. I hope that it will be understandable. Then we can use querying top K. What does it mean, top K? It means top the nearest ways to check the nearest answers to your questions, or for example, to something that you're sending. And we have two ways of doing that. It's QSIN's distance. It's smaller, like smaller is closer, smaller vectors, like you should have a lot of the database, and it will be much more strictly. I think QSIN is using mostly, and L2 distance is writing in this way. It's when you don't have so many data, so it have a little bit more distance for and more elements to take on from. So you can discover to take that and find out what you want more. Then we have updates. So when you want to update something, you of course should also update the embedding. So you're updating the text, you should also updating embedding. So that's crucial here. And right now we're going how this search will go, especially with search, ElasticSearch and OpenSearch. So it will go to the ElasticSearch. Firstly, what we can do, we can make the Docker image for working with our Elastic models and not models, like methods. And here, what we're doing, we have our table. We should create indexing of that. So we're making a request to make the indexes. What will help indexes to make? Indexes are used by SQL to finding easier and better results. So it's not about vectoring, it's about how it's faster and easier to find data, because you can have a lot of the data and indexing some custom things based for example, Postgre, for others, SQL managements. They can make all of that into the index. Imagine that as an ID for working with specific your data, and when you're querying, they're trying to reference to that index, like to the scope of what you're trying to find. So that's easier to say, that's easier way and faster to find data in your SQL, and it is being using for working with your embedding, with your vectoring search. So it's like the base to do that. And you can see an example how does it do here. We can have different types even when we are when we are not creating. Yeah, probably here we can have, I remember I have seen that one more place. Okay, probably forgot, but you can use different type. There is one HNCF, it's better results, but it takes more memory. And there is another one that I forgot, but it is using less memory and is more, like, less effective. But you can write in the comments how does it go. Then how we can ignest the data, like where we put data into our model. For example, we're doing in this way through our request, not just through SQL. And it's just the request that we can make for adding new a document, or how does it say, like in documents it means all the things. It means a document, like when we have context and embedding. So we're just adding new context with embedding to our database, so we can do this curl. And when we're searching, what we can do, we're writing KNN. It means that we're trying to find the nearest possibles to that embeddings. There is different formulas for not even KNN method. There are a couple of different others. I also don't remember all of their names, but you can find them on the internet. And K5 means that we're trying to find the 5 nearest, trying to check with embedding querying field what we are specifically querying. And now I don't, honestly speaking, remember what it specifically means, but I think that it means how many data. Honestly speaking, this one you can check out because I don't really remember what it could do for us. But this way will get back for us the 5 nearest answers for what we're querying to. For example, it will be, in our case, it could be one of the values that we're querying here. And based on that, we can take our information, our context, and for example, this question once more can be linked for some more information. So that's how it works. So we can have not only context, you can have a lot of the other information here. Context, for example, context is what we're searching. We can have, for example, not another table, we can have another fields, for example, text that we're searching. We can have, for example, answer to that. For example, we can have question, answer. And we can have here content, it will be our question. We can have, for example, answer. We are embedding the question because users will be asking mostly questions. So that's how vector will be working, and it's more about finding AI is doing. So you're not you can write really different number, or you can different words, everything different that is not in the database, but it will still find the right result because the words in vector will be similar to the answer that we are using. That's why we should use the same model to create these vectors, because if vectors will be creating different search and different data for putting in the database, we'll have different results. So these vectors helping to find information inside of database that are cannot be easily searched by simple SQL requests. For example, we can have here Paris is the capital of France, or we can have some question. How are you? We can have the question, how do you do? And from that thing, only how and you are similar. But for example, in vectoring, that could be much more closer to this question rather to hello world, open source tools, or Paris is the capital of France. So it will help us to find the thing faster and easier. And also we have OpenSearch, that is using nearly the same method for creating indexes to easier and faster creating your search, like to faster searching that. And you can discover, you can discover the difference of how it is being created. Yeah, so then we can ingest the data and we can search that in little bit different way as it was done on ElasticSearch. But also we're just trying to find 5 nearest data based on embedding, and that is our vector. That's how it is being done by the code. Let's discover a couple of best practices that we can do based on the information for the vectors. So as you can understand, vectors could be used, for example, in Amazon or shopping some information. So it's when you don't want to find in the database something based on specifically the words. For example, you can write blue car, and blue car could mean Porsche 911, some, I don't know, I'm speaking a lot of the cars. So this is an example. So vector search can have the context what is about some specific information. For example, car, Porsche, phones, and etc. So these can create the vectors and also write additional information to the database. You can also you can discover in our file, so we can have only one content and only one embedding. We can have a couple of them. So we can have, for example, a request, and we can have embedding for content, we can have embedding for author if we're talking about books, and etc, etc, etc. So we can have that based on our database. So that's crucial here to remember that how we can save our information. And once more, look at that. We are storing here only 2 informations. You will be storing more. It means that our database will be bigger. It means that we should not use data that are quite big or quite small. Quite big, it means that we will be having a lot of mesh, so something not so important. Too little, it means they won't have enough context. So try to find ideal middle of that. You can ask in Google or in ChatGPT, for example, to discover what will be the best vector here. And that's important. And also you can have more fields to discover the better way of solving it. The second thing, I don't sadly remember how this goes to another method of working with these vectors. So this method will try to find the vectors. This one takes a lot of the memory, but it's better results. So there is the second one, sorry that I don't remember that. You can try to find that in internet, and that one will be more economic for you. And for example, when you create Q&A, because this thing you can work in Q&A, for example, I think that will be more important for you because Q&A not is being used so often and not being using so many search in there. So that can help you to optimize your system. But when you're working with, for example, shopping online, so it's better, I think, to use this one. The next thing also that could work for you, try to cut chunks for your database so it will have a couple of contexts from where it can take the information. So you can chunk your documents, you can create two maybe separate database for different spheres. You can, for example, have in the next way, you can create, for example, documents for specific spheres, books, cars, etc., and have one general that can divide for which batch it is going. For example, you're making requests and it's trying to discover, what is this question is about? It's about cars, it's about books, it's about something else, and based on that, it is going to the specific table where we have more accurate result. And also that can help your local LLM, for example, when you're creating that from the scratch. So it can take the context and can create a better ask to the model. Models are doing that right now, so there you're sending your ask, it tries to understand what do you mean, and based on what do you mean, they're trying to discover based on the another database what is the answer for what you're meaning. So that's also quite important here. And don't overdo this. So it's really on the places where you won't be able to work with a specific questions. So if you have the possibility to have, for example, drop-down menu where the user will be trying to find something, or for example, you're working internally, I don't think that such thing will be needed for you because it's quite hard thing. And try to work with that only for production when you need to work with your specific clients and find such results. The next thing that is also crucial, it's finding your models on which was created that vectors, because vectors are creating that based on the models that are running on your server. So put the information somewhere. You can also create, for example, model that have been using here for creating this specific embedding. Or you can have specific table with specific timestamps when they have been created. And then, for example, you can run all the context and migrate to the new embedding system. Yes, it will take the time, but it will improve your searching. For example, you can have a new, for example, you can base that on a ChatGPT model, for example, that creates such embeddings, and there is a new update of that, and you can store the database like from this day we're using the new model. And what you should do, you should go to all the content. For example, you can have content, title, content, etc. And it tries to find all of the content beginning and tries to check embedding, and the second part, for example, here we'll have title, embedding title, and run through this title, check that to the embedding and put it into this field, so like update it. So that will help you. So try to have the same fields for content and embedding. You can just say description, you can say, for example, author, for example, or title, etc., for better finding the results. I think that's all. It's quite hard topic for me, honestly speaking, but I hope that it's much more understandable for you how these vectors are been working. If you have more questions or you want to have some more in deep data, write in the comments below. I'll take a look on that, and maybe we'll have something more deep about this topic. So I hope that this video helped you understand how does it works and why should we do that and why not. Thanks everyone for watching this video. Hope that you liked it, and please write down in the comments your thoughts, your ideas, and what you would like to see in the next videos. Wishing you all the best. Bye.